Right now, if you were standing near the equator, the ground beneath your feet is carrying you through space at roughly 1,000 miles an hour, yet you feel absolutely no wind in your hair and no lurch in your stomach. You feel nothing because you, the atmosphere, and the solid ground are all moving together at a constant velocity. It is the exact same reason you don't feel the tremendous speed of a commercial airliner cruising smoothly at altitude. This rotation governs the 24-hour cycle of our day, but it also dictates the physical path of hurricanes, and it gently stretches the planet outward at the equator, turning Earth into a slightly bulging sphere. So let's run a thought experiment. If we were to pull the plug on this invisible planetary engine and bring the Earth's spin to a complete halt, either all at once or over centuries, what exactly breaks first? Because every drop of water and gust of wind is perfectly adapted to that constant motion. Taking it away instantly turns the basic laws of physics into a weapon. If the spin ended in a single instant, only the solid bedrock would actually stop. Everything sitting on top of that crust would keep moving at its original rotational speed. This is the conservation of angular momentum at work, the force that throws you forward into your seatbelt when a car slams its brakes. On a planetary scale, inertia doesn't ask permission. The atmosphere and oceans would violently tear away from the stalled ground. At the equator, this translates to winds screaming over the landscape at 1,000 miles an hour, uprooting buildings while massive tsunamis driven entirely by momentum obliterate the coastlines. But if you travel north or south away from that destruction, the physics shift. At the exact north and south pole, the rotational speed was already basically zero. You are simply turning in place once a day, so a person standing perfectly at the pole would barely feel a breeze as the shock wave leveled the rest of the planet below them. In a sudden shutdown, your exact distance from the equator is the sole metric deciding whether you survive the initial inertial blast. Now, what if the planet's spin wound down gradually over centuries? The supersonic winds are gone, but a completely different kind of disaster plays out in slow motion. Without the constant outward push of rotation, oceans would abandon their equatorial bulge and migrate toward the poles. This receding water splits into two enormous polar seas, swallowing coastlines like Europe and exposing a barren equatorial supercontinent. Then the sky breaks. A rotating Earth creates our 24-hour day, regardless of our slower orbit around the sun. If you stop the spin entirely, a single day stretches to match a full year. Every location on Earth would face 6 continuous months of boiling, uninterrupted sunlight that would quickly evaporate local lakes and rivers. That exposure would be directly followed by 6 months of total, freezing darkness. But to find the most lethal consequence, we have to look 1,800 miles underground. Earth has a churning, liquid iron core that moves with our rotation, acting as a massive generator, the geodynamo, generating a web of protective magnetic force lines around the planet. Halt the spin, and that internal generator shuts down. The magnetic shield deflecting deadly cosmic radiation and solar winds would weaken and eventually collapse entirely. We actually have a preview of this fate right next door. Scientists believe Mars lost its own magnetic field billions of years ago, allowing solar winds to strip away the bulk of its atmosphere. Closer to home, this deceleration quietly breaks our technology. Geostationary satellites are placed in orbits timed to match Earth's exact rotation, so they hover over one spot. Slow the Earth down, and they drift blindly out of position, severing global communications. A gradual stop spares us from sudden kinetic destruction, but it systematically dismantles the geology, the global climate, and the magnetic shield required to keep anything on the surface alive. Fortunately, none of this is actually coming. There is no known natural force capable of suddenly stopping Earth's rotation. We are technically slowing down, but tidal friction from the moon drags on us at a pace so slow that it adds barely 1 second to our day every 50,000 years. The only realistic way to severely interrupt a planet's rotation is through a cataclysmic planet-scale collision. For evidence of that kind of violence, we can look at Venus, a neighboring world that was likely struck so hard it now rotates backward compared to the rest of the inner solar system. Farther out, Uranus spins almost completely on its side, bearing the scars of severe orbital trauma from the early days of the solar system. That silent, 1,000-mile-an-hour spin powers our weather, anchors our oceans, and holds our magnetic shield in place. On a planetary scale, stillness is death. We only survive because the ground beneath us has never once stopped moving.